Hi, my name is Anand and I'm a cloud support engineer here at the AWS headquarters in Seattle. Uploading an SSL certificate on your AWS load balancer is a pretty straightforward process, but occasionally customers tell me that they need a little extra help. Today, I would like to walk you through some common scenarios when certain customers might encounter some challenges during the certificate upload process, and we will see how to identify and mitigate them. Let's get started. As you can see, I have already logged into the AWS Management Console. Let's go to the EC2 console from there. On the navigation pane, under Load Balancing section, choose Load Balancer. Select the load balancer that you want to upload the certificate to. As you can see, I have already created a classic load balancer named SSL test LB. To deploy an SSL certificate on the load balancer, we need to add an HTTPS listener first. The load balancer uses the certificate to terminate and then decrypt the requests before sending them to the backend instances. I already have an SSL certificate for my domain, which we can upload to the load balancer. So let's create the HTTPS listener first and then upload the certificate. So for that, let's go to the listener tab. Click on Edit. Click on Add. For the protocol, choose HTTPS, Secure HTTP. You can see that this updates the load balancer port, the instance protocol, and the instance port. Now, for the cipher, I have kept the predefined cipher policy, which is ELB 2016-08. Click on Save. And this will keep the predefined policy as it is. For SSL certificate, choose Change and then select Upload a new SSL certificate to AWS Identity and Access Management, which is IAM. For certificate name, I'm entering Test SSL Cert. For the private key, since I already have the certificates with me, I'm going to copy the contents of private key into the private key section. For the private key, I have already copied the contents of the private key file. Now I'm going to paste it. I'm going to do the same for public key. I have already copied the public key certificate contents, and now I'm going to paste it. Lastly, for the certificate chain, I have already gotten the certificate chain from my certificate provider. So I'm going to copy the contents of the certificate chain to the console. Please keep in mind that all the three certificate files should be PEM encoded for the certificate to be uploaded successfully. Most of the certificate providers will provide you with a certificate chain file. If not, you can always check your CA's website for more details about the certificate chain file. Now that we have copied the contents of private key, public key, and the cert chain onto the console, we'll click on Save to upload the certificate. Now that we uploaded the certificate, let's take a look at two scenarios where you might encounter some challenges. The first scenario is the format of private key, the public key, and the certificate itself. As you saw in the previous section, the private key, the public key certificate, and the certificate chain should all be PEM encoded. The second requirement is that they should be in the format that I'm going to talk about now. Let's look at private key first. Private key is the one that you use to generate the CSR, which is certificate request file. Private key can either be PKCS1 format, which is the traditional format also known as SSLEA format, or it can be PKCS8, which is the newer format. Let's look at PKCS1 format first. As you can see, it begins with begin RSA private key. The contents of the private key are base 64 encoded format, and it ends with end RSA private key. This is PKCS1 format. Now let's look at PKCS8 format. For PKCS8 format, it begins with begin private key. The private key content is still base 64 encoded, and it also ends with end private key. In other words, whenever the key starts with begin RSA private key, it is PKCS1 format. It is just an RSA key, and it is essentially just a key object from PKCS8, but without the version or algorithm identifier in front. If this key starts with begin private key, it is PKCS8 format. It indicates that the key type is included in the key data itself, which is not the case with PKCS1. One thing to note is that if you are generating the private key using OpenSSL gen RSA command, the default format is PKCS8. However, you can also use OpenSSL to convert your PKCS1 format private key to PKCS8 format key if you happen to have your private key in PKCS1 format. The command for the same is OpenSSL RSA in, and new key PEM is the place where you would upload your PKCS1 private key, and out would be where you would want to store your PKCS8 private key. Because the private key is unique, one thing to keep in mind is that you should always keep it safe and handy. You won't be able to retrieve your private key after it is uploaded to your load balancer for security reasons. Now let's move over to public key certificate format. Public key certificate is a certificate that you obtain for your domain from a certificate authority like Komodo or Thaw, etc. The public key certificate format should look like this. It begins with begin certificate. The contents of the certificate would be again base64 encoded, and it will end with end certificate. That is the format for public key certificate. Let's move over to certificate chain. The certificate issued for your domain consists of certificate chain with a CA bundle. CA bundle is nothing but a file that contains the root and intermediate certificates. The chain is required to improve the compatibility of certificate with web browsers like your Chrome or Mozilla, etc., and other clients so that the browsers recognize your certificate and no certificate warnings will appear when you go to your site. A certificate chain contains one or more certificate. The example that I'm going to show you now contains 3 certificates, but your certificate chain can contain more or less. So as you can see in this example, it begins with begin certificate. Again, the content is base64 encoded certificate, and it ends with end certificate. So this was for one certificate. Like that, you can have another certificate for your root and so on. Please ensure that all the private key, public key, and your cert chain is in the format that we have seen. We just saw scenario 1. Let's move over to scenario 2. Sometimes you must have noticed that even after you upload the certificate to the load balancer, you still get the untrusted connection error message in your browser. The most common reason for this error is a missing certificate chain. As we saw in the previous screen, there are 3 files needed when uploading a certificate to your load balancer, which is the private key, the public key certificate, and the certificate chain. For an SSL certificate, if you upload only the public key and the private key certificate and for some reason forget to upload the chain, the client, which could be a browser, would be unable to follow the certificate chain to the trusted root CA that actually issued the certificate. The reason the certificate chain is optional is to facilitate uploading self-signed certificate in the console. When you sign a certificate using itself, there is no need to upload a certificate chain. It is valid by itself. Now, you can verify the missing certificate chain with the help of your browser, OpenSSL tool, or using some third-party websites. So let's see how to verify this using browser first. I have RDP'd into my Windows server, and I have opened my browser, which I'm using Chrome here. Enter the URL of the site that you want to verify in the browser first. You will see your connection is not private message, along with error message which is net error set authority invalid error. This is due to the missing certificate chain, which is what we are testing here. You can also click on advanced to see more information. Now that I'm in the terminal, I'm going to type the command OpenSSL client show certs connect, and here is where you enter your domain. Here I am entering my test domain. And followed by the port, which is 443. You'll see that the command returns code 21, unable to verify the first certificate. As the error message says, OpenSSL was not able to verify the certificate because of missing certificate chain. You can also use third-party sites to identify missing certificate chain issues. So for that, let's go to a browser and type the URL of a third-party site. I'm in the browser and I have entered the third-party site that I prefer. You can enter the URL of any third-party site that you prefer. And once in the site, you enter your domain URL that you want to test. This site, under the summary section, shows you the grade assigned to the certificate. If you are missing a certificate chain, you should see a lower grade, which is what we are seeing here. The summary also includes the reason for the lower grade, which is, in this case, would be the server certificate chain is incomplete. The good part is that this problem can easily be fixed. Search your CS website to download their intermediate CA file. This file should contain the concatenated chain of trusted CA certificates which are needed to reach the root certificate. After you find and download the certificate chain, upload it to your load balancer along with your private key and public key certificate, which we saw in the previous section, and you shouldn't see this error anymore. As a best practice, we recommend that you verify your SSL certificate after uploading them. You can verify your certificates using your browser, OpenSSL tool, or any third-party website like we saw in the previous section. Let's look at each one of them in more detail. Let's start with the browser first. I'm in the browser and I have entered the URL of my site. From the browser, you can view lots of information about your certificates. To see that, click on the log symbol, click on More Information, click on View Certificate, and you can see details about your certificate. A few key things to keep in mind are CN, which is common name. This shows the name of the domain that the certificate was issued for. This is helpful in the case of certificate name mismatch error, where the domain listed on the SSL certificate presented by the server does not match the domain that the browser is connected to. The second is issuer. It shows the entity that issued the certificate. The third would be subject alternate name extension. This shows the website addresses that the certificate can be used to identify. The fourth is valid from. It shows the date the certificate is first valid from. And finally, valid to. It shows the expiration date. This is helpful in the case of SSL certificate expired error. Let's test the certificate using OpenSSL. For that, I'm going to the terminal now. Now that we are back in the terminal, we can use OpenSSL S client to verify the certificate. From the command line, we just need to run this command: OpenSSL S client show certs connect. Enter the domain URL that you want to verify. Here I am entering my test domain, followed by the port, which is 443. You will see that the verify return code returns code 0 OK now instead of 21, which we saw earlier. This means that the certificate upload was successful. Now let's test the certificate using a third-party site. For that, I'm going to the browser. In the browser, enter the URL of the third-party site and enter your domain URL that you want to verify. The output should contain the information regarding the server type, certificate expiration date, and the complete certificate chain information. As you can see, for my site, everything looks good. Finally, there are alternate ways of uploading certificate to your load balancer. You can use ACM, which is AWS Certificate Manager, to upload your third-party certificate to load balancer. ACM handles the complexity of provisioning, deploying, and managing the SSL certificates for your AWS-based website and applications. ACM also requires the certificate to be PIN encoded, and the format of private key, public key, and the certificate chain should be the same as we discussed before. With ACM, you can purchase a certificate directly from Amazon. After you purchase a certificate, the procedure to upload the certificate to your load balancer is really simple. Let me walk you through an example. For that, I'm going to go back to the load balancer page again. As you can see, I have already created another classic load balancer called test SSL2. I also have an SSL certificate provisioned using ACM for my test domain. In order to deploy that SSL certificate to the load balancer, we are going to add an HTTPS listener first. The procedure is very similar to what we saw in the earlier part of the session. Let's go through this again. Go to the Listeners tab first. Click on Edit. Click on Add. Choose HTTPS protocol. And under the SSL certificate, click on Change. The main difference is the certificate type this time. We're going to choose an existing certificate from AWS Certificate Manager, ACM instead, and then select the appropriate ACM certificate, which would have the name of your domain, and then choose Save. One last thing to keep in mind is that ACM is region specific, whereas IAM is global service. What I mean by that is that when you upload a certificate to IAM, it is available for all regions under your account, whereas the ACM certificate needs to be in the same region as the load balancer that you are uploading the certificate to. Thanks for watching, and happy cloud computing from all of us here at AWS.